Welcome! Today we're exploring Semantic Kernel, Microsoft's enterprise AI orchestration framework. This is a mature, polyglot SDK that helps developers build sophisticated AI agents with pluggable tools, multi-agent coordination, and support for pretty much every major LLM provider out there. Let's start with the basics. Semantic Kernel is a substantial codebase spanning 3 languages, C#, Python, and Java, with over 500,000 lines of code. It's designed as a multi-language AI orchestration framework, giving you a consistent programming model whether you're in .NET, Python, or the JVM. It integrates with over 15 vector databases and supports every major LLM provider, from OpenAI and Azure to Anthropic, Google, and AWS Bedrock. So, what does Semantic Kernel actually do? Think of it as your AI service bus. You register LLM services and define plugins functions that your AI can call. Agents wrap those chat completions with persistent state like instructions and chat history, plus access to your tools. When you need multiple specialists, the multi-agent orchestration layer coordinates them with shared context and routing strategies. And when your agents need to search knowledge, the vector data connectors plug into Chroma, Qdrant, Pinecone, and more for retrieval augmented generation. Here's a look at the tech stack under the hood. On the application side, Semantic Kernel builds on Microsoft's AI abstraction layer, the official OpenAI SDK, and Pydantic for Python validation. For vector data, it supports ChromaDB, Qdrant, Pinecone, Weaviate, and several others, all behind a unified interface. And on the services front, you've got Azure AI projects for managed agent runtimes, OpenTelemetry for observability, and the Model Context Protocol for agent-to-agent communication. Let's zoom out and look at the architecture. At the center is the core kernel, your service bus, and execution context. The agents framework sits on top, wrapping chat completions with instructions and tools. The kernel dispatches requests to LLM connectors, which abstract away provider differences. OpenAI, Azure, Anthropic, Google, you name it. Vector data provides semantic search, and the runtime layer orchestrates multi-agent messaging. It's a layered design: kernel, agents, connectors, orchestration. Here's how a simple chat completion works. The user calls invokeAsync on a chat completion agent, which assembles the chat history, injects system instructions, and asks the kernel to resolve the right chat completion service. The kernel dispatches the request to OpenAI or Azure or Anthropic, whichever you configured. OpenAI returns a chat message content which flows back through the kernel and agent, and the user gets a clean agent response item. The agent hides all the plumbing. One of the most powerful features is automatic function calling. You register a plugin, say a menu plugin, with methods like getSpecials and getItemPrice. When a user asks, "What is the price of the soup special?" the LLM decides to call getSpecials first, then getItemPrice. The kernel automatically invokes those Python methods, collects the results, and sends them back to the LLM. The LLM synthesizes a final answer, all without you writing any routing logic. It's like having an assistant who knows when to look things up. Multi-agent orchestration lets specialists collaborate. Imagine a customer support system with a triage agent, a billing agent, and a refund agent. The triage agent has the other 2 as plugins, meaning it can invoke them as functions. When a customer says, "I was charged twice," the triage agent decides it's a billing issue and invokes the billing agent. The billing agent investigates and returns a diagnosis. The triage agent synthesizes a response, all in one turn from the customer's perspective. It's like a project team passing tasks around. Vector search powers retrieval augmented generation. You chunk your documentation, generate embeddings, and upsert them into a vector store like Chroma. When a developer asks, "How do I retry failed functions?" the agent embeds the query, searches Chroma for the top 3 most similar document chunks, injects those chunks into the prompt, and asks the LLM to answer based on the retrieved information. The LLM generates an answer grounded in the actual docs. If the docs update, you just re-embed, no code changes needed. Let's talk about the community. This snapshot shows the repo is actively maintained. The last commit was just yesterday, which is great. Over the past year, we see modest commit activity, with one contributor actively committing in the last 90 days. It's a corporate-backed project, so you'd expect a smaller, focused team rather than a sprawling open-source crowd. 2 branches, no release tags in this snapshot, which suggests this might be a development branch or a fork. The repo is alive and being worked on. So that's Semantic Kernel in a nutshell. The big idea is composability. Functions become plugins, plugins become agents, agents nest into orchestrations. You build from simple chatbots to complex multi-agent workflows without switching paradigms. Just add layers as your needs grow. It's a powerful foundation for anyone building AI applications at scale. Thanks for watching and happy building!